Hello friends, and welcome to Webronaq. Here is a question worth thinking about. If someone asked you right now what the slash directory is on Linux, could you explain it clearly? Most people learn it once and move on, but in 2026, not knowing it became a real security problem. In April and May of this year, a Linux kernel flaw called copy fail, tracked as CVE 2026-31431, let any unprivileged user silently corrupt the in-memory copy of a setuid binary like /usr/bin/su to gain full root access. Then in June, a second exploit, pitted cow-w, did the same thing through a completely different kernel path. Both attacks worked precisely because those paths under slash are where Linux keeps its most privileged programs. The root directory tree is not just a folder layout. It is a live security boundary. In this video, we are going to understand exactly how it works. Alright, so what exactly is slash? On Linux, slash is the root directory, and it is the single starting point of the entire file system. Every file, every device file, every network mount, every directory on the system lives somewhere underneath it. There is no such thing as a file that exists outside of slash. That is a fundamentally different idea from Windows, where each drive, C:/D:, gets its own separate root. Linux has one tree, and slash is the top of it. Now this layout is not just a convention. It is defined by a living specification called the Filesystem Hierarchy Standard, or FHS. Version 3.0 of the standard was published by FreeDesktop in April 2026, making it the current authoritative reference for how every directory under slash should be organized across Linux distributions. Knowing that spec exists means you are never just guessing at why a folder is where it is. Now look at this. The easiest way to hold slash in your head is as an inverted tree. Slash is the trunk. Every directory beneath it is a branch, and the individual files inside those directories are the leaves. Everything in the system hangs from that one trunk. Here is the part that surprises people who come from Windows. When you plug in a USB stick or connect an external hard drive, Linux does not give it a new letter or a new root. Instead, it attaches that device as a subtree somewhere underneath slash, typically under /mnt or /media. So the drive becomes /mnt/USB0, a branch of the same tree. The whole machine, every storage device you attach, shares one unified hierarchy, rooted at slash. This model is clean and consistent. Once you understand it, navigating any Linux system becomes predictable. And as we are about to see, that predictability extends all the way to the names of the directories waiting for you under slash, because the FHS maps them all out. Alright, let's walk through the directories you will actually find sitting directly under slash. The Filesystem Hierarchy Standard, or FHS, defines what each one is for, and the layout is remarkably consistent across all major Linux distros. /bin holds essential user commands like ls and cp, the tools you cannot do without. / and so on is your system configuration. Think of it as the control room. /home contains each user's personal space, so /home/Alice is where Alice stores her files. /var is for variable data, logs, mail queues, databases that grow over time. /dev gives you device files. Every disk, terminal, and random number generator appears as a file here, which is a beautiful expression of the Unix philosophy that everything is a file. /usr/bin, often the largest directory, holds the applications installed for all users. And /tmp is temporary storage, wiped on reboot. 7 directories, one coherent system. In the next slide, we'll see who actually owns these directories and why that ownership becomes a security boundary. Here is the interesting part. All those directories we just toured are owned by the root superuser, and a normal user account cannot write to them. That is Linux permissions in action. / and so on. /bin and /usr/bin are locked down so only root can modify them. This permission boundary is exactly what attackers try to break. In April 2026, a kernel vulnerability called copy fail, tracked as CVE 2026-31431, showed how serious that is. An unprivileged attacker could corrupt the in-memory version of /usr/bin/su, the binary that switches your user account, without touching the file on disk. That gave them full root access. CISA added copy fail to its known exploited vulnerabilities catalog. The lesson is direct. The permission walls around /usr/bin are real protection, and when those walls fall, the entire system is exposed. Which brings us to what you should do about it. Alright, let us bring it all together. Linux has one file system tree. / is the root. The FHS names every branch, and the permission model guards every critical path. When you know that / and so on holds config, /usr/bin holds programs, /var/log holds logs, and /home is yours, you can navigate any Linux system with confidence. The copy fail exploit from April 2026 is a reminder that these are not just tidy labels. They are real security boundaries, and keeping your kernel patched matters. 3 commands will get you started right now. Run cd/ to jump to the root. Run ls/ to list every top-level directory. And run man here to read the built-in hierarchy manual on your own machine. 1 tree, 1 living standard, and 1 very good reason to keep your system current. Thanks for watching, and we will see you in the next one.